Hello everyone. In this video we are going to talk about the number I to the power I, and I am very happy to present this video today. Well, so what is I to the power I? I is a complex number which is square root of -1, and I to the power I is really complicated, right? We even don't know what is the meaning of I to the power I. Okay, this is a mind-bending math problem, and as it says, I to the power I is a real number, which is against our normal intuition, right? And this problem is also a very popular interview question. Okay, this is favorite of interviewers, and therefore you must always keep in mind the proof of this. Okay, why I to the power I is real. Anyway, so we are interested in finding the value or values of I to the power I. Okay, we'll see that I to the power I has many values, infinitely many values actually. Okay, yeah. So before we calculate the value of I to the power I, we must know what is the meaning of this symbol I to the power I, right? Yeah, so suppose a not equal to 0, then a to the power z, where a is non-zero, of course complex number, and z is another complex number which can be 0. Z can be 0 but a is not 0. Then a to the power z is defined by this expression, exp of z log a. Okay, and this is capital log because L is written in capital. So, and x is called the exponential function, and log is of course log. And therefore, to understand the meaning of even the meaning of a to the power z, we need two more functions, exp, which is the exponential function, and log, which is the logarithm function. Okay, then first we must know what is the meaning of exp. And interestingly, this log function is defined again using the function exp. Therefore, we first must know what is exp. Okay, so exp is defined by this. X plus iy is any complex number. Okay, it can be 0, it can be any complex number, and that is of the form x plus iy. Okay, so for any x plus iy, x plus iy is defined to be e to the power x cos y plus I swan y. Simple. So x is any real number, y is any real number. Okay, for any of these real numbers x, y, okay, e to the power x and cos y, they are always defined. Therefore this definition is well defined. And why we are using exp here but x e to the power x here? Okay, exp is also exponential, e to the power is also exponential, but exp means when we apply it on complex number, then only we write exp. And if it is real, we know, then we can directly write e to the power. Okay, that's the meaning. Well done. So then, for example, if you take r bigger than 0, okay, r is bigger than 0, suppose, then what is this number, exp of log r plus I theta? Can we calculate this? Yes, because if r is bigger than 0, log r, basically small log, this is defined, and theta is the number here. Theta is any number actually, theta is any real number. So exp of log r plus I theta, this gives what? By this definition, okay, it must be e power x. Okay, e power x, x is log r, so e power log r. And what is y here? I y is theta here, right? Therefore cos theta plus I sin theta, right? But this small log r and e to the power that gives you what? E to the power log r is simply r, and what was there is written here, cos theta plus I sin theta. And this shows something interesting. Okay, if you start with any complex number of the form r cos theta plus I sin theta, and any complex number can be written in this form, this is the polar form, right? Then for that complex number, there is a complex number which is log r plus I theta. So basically, given r cos theta plus I sin theta, I will take r, find the logarithm, I will write here, okay, as x, and I will pull theta from here, I will just write plus I times that theta. This is again a complex number of the form x plus iy. And we see that for any r cos theta plus I sin theta, we have a complex number log r plus I theta, whose exponential gives you the complex number back. Okay, so what does this imply? Okay, this implies for any complex number z equal to r cos theta plus I sin theta, which is not 0. Okay, because if it is 0, r will be 0, and we cannot take log of that, right? Therefore this is not 0, but any complex number other than 0. Okay, for this there exists another complex number, okay, w, and we know the expression also which complex number it is, that is just log r plus I theta, such that exponential of w will give you exponential log r plus I theta, and that is nothing but r cos theta plus I sin theta. From the previous page calculation we know. Okay, so which means what? That is again r cos theta plus I sin theta is just z, which you started with, right? So for any complex number which is not 0, for any complex number z which is not 0, there exists a w is given by log r plus I theta, that is the expression of w, such that exponential w gives you z back. Okay, and this is very important. Okay, so there is another observation which is very important. Okay, just suppose exponential w is z, okay, for some z, then what is exponential w plus 2n pi I? If you want to calculate, this is just exponential of log r plus I theta, because w is log r plus I theta, plus 2n pi I as it is. Then exponential, this becomes, I am using third bracket, this becomes log r plus I into theta plus 2n pi. Very simple calculation. Okay, and then exponential of log r plus I theta plus 2n pi. From here you can see exponential log r plus I theta is r cos theta plus I sin theta. So here r cos theta is now theta plus 2n pi. So r cos theta plus 2n pi plus I sin theta plus 2n pi. But cos theta plus 2n pi is what? It is again cos theta. So what we get is r cos theta plus I sin theta, which is nothing but z. Okay. So we have seen that if exponential w, where w is log r plus I theta, is z, then exponential w plus 2n pi I is also z. Okay, so this w plus 2n pi I is an infinite family of numbers whose exponential gives you just z, if exponential w is z, right? Okay, fine. So now we are back to definition of log z. We want to define log z, okay, for any complex number which is not equal to 0. Okay, how to define it? So log of z is defined to be, capital log of course, is defined to be w if the exponential w gives you z. Okay, the definition should be clear. The log z, one of the values of log z is w if exponential w gives you z back. Okay, now we have seen if z equal to r cos theta plus I sin theta, then w can be taken as log r plus I theta, because exponential of log r plus I theta is r cos theta plus I sin theta. This we have seen. Okay, so what it says? It says exponential w plus 2n pi I is also z, because exponential w is z, and therefore log z is multi-valued, and since all these numbers, okay, after which exponential is applied and giving z, all these numbers must be logarithm, because that is the definition. If exponential of some number gives you z, then that some number will be logarithm of this. Now w plus 2n pi I, all of them are giving z, therefore all of these are log z, and clearly log z is multi-valued. Okay, so if z equal to r cos theta plus I sin theta, if we write z in the polar form, then what happens? Then log z is nothing but w plus 2n pi I, w plus 2n pi I, but w is what? Log r plus I theta if z is r cos theta plus I. So what finally we get, if z equal to r cos theta plus I sin theta, then log z is log r plus I theta plus 2n pi I. Okay, and this is important. Now z is a complex number, we know the general expression here. So what is the logarithm of I then? Okay, that's a valid question, but this is also easy. Okay, first write I in the polar form. What is the polar form of I? This is just cos pi by 2 plus I sin pi by 2, and r is what? The r value is 1, because r is the modulus of I, which is 1. Fine. Okay, so then what is the logarithm of I? Okay, logarithm of I will give you what? We have seen that this is log r plus I theta plus 2n pi I. Now r is 1, so log 1 plus I theta, theta is pi by 2 here, so pi by 2 here, plus 2n pi I, right? And small log of 1 is 0, therefore we get I pi by 2 plus 2n pi I. This is the value of log I. Now we are back to our original problem. If a not equal to 0, we know that a to the power z is defined by exp z log a, right? And now I to the power I value you want to calculate. Okay, so basically here a is I and z is also I. So from the definition you can write it as exponential I log I, right? And now we know the value of log I. Okay, so then it is exponential I, and log I is I pi by 2 plus 2n pi I. Okay, and I comes out from here. Okay, and that gives minus 1 I into I. So basically exponential of minus pi by 2 plus 2n pi I. Now you see that there is no I and it's a purely real number. Okay, everything is real number. Therefore, we can write in particular, instead of x, we can write e to the power minus pi by 2 plus 2n pi, the same number, right? Okay, so at least we see that I to the power I is all real. Okay, and you can take n to be any integer. So basically I to the power I is multi-valued as expected, and e to the power minus pi by 2 plus 2n pi, these are the values. Now if you wonder what is the principal value of I to the power I, we always ask for the principal value, right? Well, the principal value of I to the power I will be what? Principal value of I to the power I corresponds to n equals 0. So if you put n equal to 0 here, you get e to the power minus pi by 2, which is a very precise real number. Okay, yeah, so that's why this problem is interesting, and the proof is also interesting, and we also must know the intricacies like what is log, capital log, what is exp, right, and what is the difference between exp and e to the power, right? All of this we have discussed in this video. Okay, and that's all in this video. If you like the content, do press the like button and subscribe our channel to motivate us. I sincerely thank you for watching this video.